Hello everybody after lunch. I welcome you on the last tutorial. It will be related to lecture 7. So we are working with MTI filtration, we are working with UKF and AMPD algorithm, and at the end we will work also with real data measurement and how our mitigation algorithm works on not only synthetic simulated data but also on real data. It is the last tutorial, and after this tutorial we will make lecture 8 that will be shorter one, and it is about conclusions and future work. So we'll see how much time we will need it to pass through all these things. So first, this tutorial will be exactly follow our mitigation chain. So we put all together to complete practical chain for analysis of wind turbine based on microdoppler in real data. We start from raw spectrogram. We will go firstly through AMPD testing algorithm. First, I will show you on some, how to say, test data. So it is mean it will be just few harmonic signals, some of few harmonic signal, some Gaussian signals, and so on. And then we will apply AMPD algorithm to the spectrum. Then we will continue with MTI filtration. MTI filtration, I will show you which parameter is based, which parameter we use for this filtration. Then will be extraction of DSC component, then UKF example, extraction data, UKF simulation and measurement, and then will follow complete analysis of mitigation algorithm on different sites. And again we will follow strictly this free site where we already working, like yesterday when you are working during designing scenarios. So what is automatic multiscale based peak detection? You just heard before 2 hours, so I will be little quicker. Goal is detection of the three highest peak in spectrum, and based on this estimation we will put like input to our UKF filtration that will estimate or extrapolate future values based on which we design a filter and we use it for filtration. So please open tutorial 0401 test AMPD, where input variables will be standard deviation, sigma and kk. I will call it width where is local maximum search it. So it is mean if you will have higher and higher higher value of this parameter, it will ignore more and more, how to say, local small maxima caused by jittering. So please open MATLAB. Do you have a tutorial for ready? Good. And now please just start with this type of signal. Later you could play with other type of signals. So the last one, and base kk parameter is 40. So it is something like a length of window where you apply this one, this algorithm. Some computation will be more demanding, so please be patient. So if you can check without noise, we get something like this. It is localization of maxima on some periodic signal without any mistakes. Of course there is noise, so there is no issue, just detection of maxima by algorithm. If you check on second one and zoom to some some maxima, localization of maxima is this green dot, and it is not exactly fit to maxima, but it is hard to even predict where is this maxima, of course, because there is amount of noise. So please try adjusting kk parameters. Now is standard value 40, try adjust it like to 30 and run again. So if you can watch it, there is of course another noise because it is random, but I think that you can easily watch it that also there will be more and more some mistake with the definition of this maxima. Try go lower and lower and lower and lower. Okay, and now it is first example 420, because the like size of window, if I can call it, it is now too low. So even in this period he defined one, there one, there one, but due to noise, there he is not sure how I can be. So make identification of two maxima, there some maxima, because why? Because behavior of this noise signal is some big differences between amplitude, so he will define that he decide, okay, there is also maxima. But you can say it is not true. So it is clear that if you get again lower and lower, there will be more and more and more and more these green dots where local maxima is identified. But it is not mean that is wrong, if you get my point, because it is depends on setting. Of course, for our mitigation algorithm based on measured data, we just discover some optimal value. So we are not changing this value during processing. But now we are playing with algorithm, so we can change it. So please try go even for lower values, so we can go like for 5, and on which depends this parameter, on type of signal, what is some best value for you. Again, you need to tweak. Check. There is a lot of local maxima because the window size is relatively low, so he not make like waiting, averaging in a very short time, and then it's clear that he have identification of more of them. Maybe just try just opposite, so we will put like 8, okay, like 80. Okay, it is good example. Check this one for 80. He ignored this because it is so big window that again it is just opposite case. He, due to this algorithm behavior, he decide, okay, there is no maxima. So if you will go up, 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 then will be lower and lower number of maxima. It's just opposite. Kk lower, more maximas, kk higher, lower number of maximas, because it is the, like waiting. Please try also go back like to some standard value like 30, 40, and try another type of signals. this is relatively good localization of maxima, everything for this 30. And of course, without noise, it will be again perfect. I didn't show you for other cases without noise because it is no meaning, because there it is just clearly nice curve, so there is no issue about identification of local maxima. So I think that this functionality is clear. Please try open this EMPD demo application. There is some more multiple signals. It is also with Guy. There is little, I just consider if I want to show you this application or not, because there is tricky setting between both parameters that you can visible. There is a predefined multiple signals. So signal 1, it is just combination of harmonic function. Signal 2 is sum of Gaussian functions, so like spectrum like peaks, because it is Gaussian, it looks something like this. And signal 3 is sum of two Gaussian peaks like controlled spacing. So if you will set noise parameter standard deviation sigma to null, so it is like without noise again, and result is our signal, it is black curve, and blue triangles, it is like naive local maxima approach, where condition is YE is higher than YE plus minus 1, so it is like very naive approach for identification maxima. And the red one is of course AMTB algorithm. So please run this application. And when you have scenario clean, naive as MTB, so you can see that there is no issue. Sum of Gaussians again, naive approach, blue one, and AMMPD, red one, you can see also no problem. I put this example of sum of Gaussians due to similarity of shape of DSC component. And the last one is close to twin Gaussians. It is close one. What does mean this one? When blades are close each other for some this spectra, how it's rotating, how it's moving, so you know that we have sometimes they are overlapping. So this is almost overlapping cases, but of course we need to identify both maxima. So it is just like typical examples, but it is without without noise. So okay, okay, effect of sigma. There you need to switch effect of sigma and check now. It is for some setting of noise. I hope that will, yeah, it works. Okay, if I will go with sigma of noise to 0, it is my clear approach and there is nothing. And you still remember this is this naive approach, and it is just comparison of two consequent like samples, what is higher. And very, very slowly increase this behavior, and you can see that this naive approach totally failed, even for a low number, because you can see how many identification of local maxima is with this naive approach. Of course, this can't working because it is just adding noise, so there is jittering, and he consider almost everything that is local maxima. But check AMPD algorithm. Maybe now you will start complain. Okay, but still there should be only 2 of them, and I see a lot of red one. Of course, much more lower number than with blue one, but still. Why? Because I didn't tweak parameter KK. And it is exactly what I want to just describe. Be careful about this, because we always need to tweak some specific value in our cases. So it is algorithm. You need some tweaking of this. So you can, if you will increasing, there should okay, you can see if I will go up, there will be low number, but even in this one, because they are really too close the sum. If we will go for another, like sum, you can see blue one and red one, almost perfect. Okay, there is, due to some settings, still one remaining, but you see that localization of this local maxima is relatively stable. So please, 2-3 minutes, play with this setting, try it. If you have question, I will come and answer you. Just try it, play with different parameters. This is like, if this number will be higher and higher, it will be like more averaging, if I can say. So the smaller local maxima will be more and more ignored. But this is very, very big one, so this should be still stable. But maybe for 80 it is relatively extreme value, even this one disappear. Just check it, please, because there is a lot. This is just combination of noise. I recommend you tweak always one parameter, not both, because it is hard to discover what is influence this parameter when you are changing in same time noise and same time this parameter KK. So okay, you can see for 45 we have 3 maximas. Blue one ignore, because it is, of course, it's totally failed. But if I will go to extreme, no, okay, check, he identify like 2 maximas only, even for this, but it is extreme value 80. So, and now we will set like this one. Okay, this is, yeah. So if I'll include the noise for some or harmonics, you can see blue one bad, but red one, even for more and more noisy, still works pretty fine. And still works, because there is big differences. So you can see that local maxima bar AMPD relatively works nicely. And if I will change KK, what this mean? That I will take bigger, like averaging window, windowing, and then even start ignoring me this local maxima, because it is too much big. It is too much big value. So like this one. Okay, it is too much big noise, it is almost 1. There could be visible that even for closed twin Gaussians, algorithm will have sometime problem, because they are so close, and second is smaller and hardly visible, that this local maxima for some amount of noise will be hardly visible. So if I will go with noise low, it should be improving, but still there will be some remaining. So So it was first scenario. Second scenario, it was sum of Gaussian. This one, this effect of KKs for second scenario, you can see that naive approach working. Of course, we don't have noise. AMPD peaks for KK, it is the red one, works. For green one, KK12 works, but for purple one, KK30 didn't work because it is not so big one, and he will ignore him this algorithm AMPD. So it is this one. Another scenario is noise environment. It is effect of noise. So in case that you increase sigma, naive peaks, I just call it explode because I don't know how to describe anyway, it is just stop working. You can't use it for which value you want to use it. Free the strongest from the blue one. MPD still show a small stable set of peaks. I don't say that there are 3 of them or something, but really small set. But again, depends on KK, so you need to tweak. But of course, for some scenario from wind turbine could work some value, for some another value. Okay, sometimes failed, but for this reason there you have UKF that still won't make it is bad measurement. Believe more prediction and so on and so on. So you have like a little control mechanism of this output. Sometimes happen, it is depends. So, and the last one is scale with noise. It is influence of KK. So small parameter, high resolution, but low robustness. I could show you a lot of results that are they are not true. It is just local maxima, but we don't want this local maxima from point of view DSC. So medium KK spacing gets larger, want to use more scales, naive peak, it is still mass, AMD peaks, mostly just 3 main peaks, so relatively work. And for large value, even our DSC sometimes can just disappear due to fact that we make big windowing function. So, if I can say about MPD algorithm, small, more sensitive, resolves closely spaced peaks, but also let through noisy peak. So this noise, it is generally depends on noise. If will be noise very high, you will see a lot of peaks that you don't need. Medium, good trade-off between resolution and robustness. So something like this, good value between 20 to 30, something like this, what we are using. And now it is important, it is also depend if you are using or synthetic data or real data. But synthetic data is just for simulation and tweaking on these parameters and for analysis. Large KK, it is very robust to noise, but tends to merge or suppress nearby peaks. So if you have like 2 blades close each other, again, it causes problem. It will be very well separated without any problem. So next will be MTI filtration on time Doppler map. It is MTI notch filter. The goal will be suppression of zero Doppler clutter. So it is mean I want to suppress static or very slow object, because even movement of trees or jittering of some towers and so on. Even tower is not static object, of course, because always there is some small movement, and even this small movement costs you some Doppler shift, but maybe plus minus 1, 2, 3, 4, 5 hertz, something like this. So we consider this that is almost static, and we also want to remove. So for solution of MTI filtration is called a notch filter. in the Doppler time means that is zero Doppler, and we want to remove. We must remove because it is strong, so strong reflection that our UKF will always select, or AMPD algorithm always select this value. Yes, it is your 1 DSC, but it is not true, of course, this DSC, because it is just our. Sorry. Static clutter occupies a large part of the receiver dynamic range, can mask moving target, especially with low radial velocity. So imagine that you have, okay, some example, UAV that is not moving, just record something what is forbidden, but is in the same position. Of course, there will be rotation of blades, but this is micro Doppler. And what I can say, on the higher distance, the micro Doppler could be masked because it is not so big reflection of this micro Doppler. It is this periodicity of micro Doppler. You can recognize. If you recognize, okay, you will detect it. If not recognize, it could be almost like static, if you get my point. So idea of MTI filter, or this is design filter with transfer function that has deep notch around 0 Hz. What does mean? Yeah, I will just remove it. I will just make filtration, okay, for easy imagination in frequency domain. So I will take my spectrum, multiplicate it with this transfer function. If it's around 0 is this notch, then we'll remove it everything around this 0. Now depends how you will set this notch filter, because how I can see this notch can look like this one, very narrow, or wide one, and so on and so on. So to simplify, to visualization, please run MTI demo application. It is this one. You should see something like this. Working for everybody? So there is original Doppler spectrum simulated. You can see that there is this free harmonics. It is this is again flash, and this is design of my filter, and there you can see two parameters, width and pole radiation. So it is pole radius, how I am closer to unit circle, and it is width. This is notch width parameter that you are setting. So please, this width just define you this place, how far away around 0 circle. If you go to, okay, we will play with it. If I will go to like extreme 0, you can see that it's not like this, but there is some width. It is, and if I will continuously increasing, these two lines go to each other and each other and each other. Please be a little patient, because I know that you quickly click, but sometimes take a computation. So it is depend on speed of computer, and if I will go maximum, it will be almost together. Always please watch filtered signal. You can see it is wilder, and if it's wilder, then bigger part around 0 frequency is removed. But just be patient. So set maybe 200, something like this, and we will go oppositely, just put to pole radiation, influence. You see now if I will set pole almost close to unit circle, what this mean? That the zero and poles are really close each other, that will be extremely narrow, and only really small part will be removed. And now please just tweak this parameter and go down, and you will see that this will be wilder, so I will remove more. And now you need to tweak to your application, because of course if something will be very low speed, then will be your target somewhere around, and it is just controlling mechanism for MTI filter. What you consider that is still static object and what you consider that is not static object, it is up to you, like radar engineer, something like this. So it is about just designing filter. I show you just principle. So slowly go with this parameter down and watch always magnitude response, and watch please final static clutter suppression. Okay, check this size will be higher and higher, wider and wider. So just play. I will give you 1-2 minutes to play with it, and there you have data source, if you can saw it. And please, after you finish with your setting, just switch to measurement. It is already pre-processed data. I will show you. It is generally like spectrum simulation. It is MAT file. It is just metric with data. It is spectrogram if you open, and this is spectrogram of real measurement. Oh, sorry. Just play it with this and check. I just remove it and just rest of my signal. And now play it again with parameters, please. I will give you 2-3 minutes, just what is influence of the both parameters, because there is no description. It is better interactivity on your PC. If you have any question, I will answer you. So if I will go with pole radius to higher values, this will be more and more steep and more close each other, so it will be more and more narrow, and this is controlling of width. So you need to find combination of parameters that you desire, that you want, that you need. There, I can't tell you that exists only one good solution. It is not true. It is filter. It is up to you which filter you want to design, what you want to suppress. But now, after MTI suppression, I can go for UKF. Works for everybody? So about design of notch filter from point of the view parameters, we design it in Z domain, place zeros on unit circle because we will just it will be deep notch what we want to suppress, and pole slightly inside the unit circle with same angles, so it will be narrow and controllable parameters. There is two parameters, width and pole radiation, and you already play with it what is time. So output figures we already described, so I think that I can continue. Now we will go to DSC extraction. So prerequisite is that you already have sampled IQ data of radar signal, you already apply MTI filtration, and so you already remove static clutter, because you can't use this one, always will be one DSC as some other, but we want to detect this free, this, and so on, always in each cut. So in synthetic data will be like this one. So there is extraction of the DSC component. If you will please first run tutorial 04 extraction. It is without guy. And this is result for KK5. Please make zoom on your PC on some part that you want to see, and this small dots, it is extracted DSC component. But how I already told you, it is relatively hard to see in extracted data, and sometimes some values for some KK you can see it is not fit in good position. Why? Because KK is parameter of where is detection of local maxima. So try tweak this parameter, just use another value of KK and try different some value that will be bait. It is on a number 48, so plus try 10 and again change and run it and try check what is results. 20, 30, 40. Just continue please with this one. This is for 10, but it is hardly visible. Please run it on your PC, because it is better always zoom area and try see which these three dots in the same row which is located, and try this parameter for 10, 20, 30 and 40, and maybe you could try then some higher value, but I recommend you up to 40, something like this. I will give you 3 minutes to testing. Just change this KK. It is line 48. But if I will make a lower this image, you can see where is the, how to say, colorful area, where is higher amplitude. So for sure it is always around this value. So, but it is hard to, hard to see this extraction because there is a lot of value. And also check around this flash, there is some problem, there is some extracted value that definitely not fit there due to flash, because he need to choose some value, but it is almost all constant, very intensive value. So try 20, 30, 40 please, and let me know. So if I will put 20, I will get this result, and so on and so on. So please try it up to 40. And one tweaking, check there. There you have parameter mass. It is mean measurement is equal 1, and if you put 0, it will be or simulated data. So try it also on simulation, because there is better visibility due to unpresence of this noise, of course. So you can see that extraction will be always this harmonic DSC. So I will finish this. Yes, and there is nicely visible. Check about this one, that he extracts two values that are each close other, and of course if the sum of all must be 0, then we will just recompute from these two values last one, because it was like F3 Doppler frequency is equal minus F1 plus F2. So he will get results really some high value of Doppler frequency, because results must be always 0, or it is close to cross section, or close to values that are very low, so the last one must be very high or something like this. But now please try tweak it on simulation data. Just put to mass. Okay, I will go down again and put mass 0. Okay, check. There is really nicely so it influence of flash, where this algorithm failed, of course, because we don't know what to select, because it is everything is spectrum is almost very hardly influenced. So he see this value, these two values, because they are highest at flash. But next one to be 0, all three, it is this one. So now please try change, try found me parameter key that will be nicely visible all three sine waves, because already they are this visible, but try to tweak to be better resolution of visualization, better visualization of these three sine waves. Try it, and I will expect what you are told me, which parameter, what will be value of this parameter. So I will try also. There is relatively good visibility. Okay. always this, of course, this algorithm failed around this flash. Not fail, it is worst result, not fail completely, but
Around
70. It is very high. I have different value. Okay, let me check 70. 17 or 70? 70. Let me check. Okay, I get your point. It is very nicely visible, but also there is a lot of error. So I am not. I would maybe better agree with about 40, 30, 40. By the way, about it's true that about flashes always is not so accurate, of course. Now you can write, you can run MMTD extraction app, but I must say that this app is relatively, how to say, computationally demanding for my PC and sometimes cause problems. So, okay. This, okay, you don't see it, sorry. It is very similar to previous, only it is with Guy, and one thing is that there is, you can make like MTI filtration or enable or disable. So if you are disable, you will see that most of results will be detected one DSC components around this zero frequency. But the meaning of application is same like previous script KK. This color bar, it is just color visualization if you need to tweak, and slice time, it show you just cut in spectra. So please try found time that you just hit the flash, because what will be in spectrum? It will be almost constant. So try to find exact time of one flash. This one, this one, this one, or this one. It is up to you. Just try it. I will also try, so I will remove, just try it alone. Also try enable and disable MTI filter to check how works with MTI and without MTI. And without MTI, a lot of these extracted points will be around zero. Check this. Now I am in time 1.14, and if you will zoom it, it will be close to this flash. And if I will go 1.2, around 1.2. Exactly. Now check. Before I am minus 20 dB, something like this, some maximas. If I go 1.2, I am completely up, and my full spectrum is just affected, and half of them of course is affected and half is not, because, and if you will go to double, so about this value, so we can zoom, because I don't know what is 2.2, it will be 2.2, yeah. It will be just opposite side of spectra. Okay, yes, now exactly, I just jump to up and just cover everything, and imagine that you have target somewhere, and now jump during flash and you can't see anything. try also enable disable this filter. And check. If I will disable filter, there is just white line because always this extraction algorithm told me, yeah, the strongest DSC component is 0, 0, 0, 0. And then select one and next just compute. And again 0, 1, compute, 0, 1, compute, and so on. Or something really close to 0, but you can see this one. And this is bad. It will not working because it is not true. It is same like if you will ignore one sine wave. If you will do it like, how to say, two blade and tower. And there you can visible formula for computation, this last one. So AMTB select 2 and next recompute. Select 2, compute, select 2, compute. So you always see three points. So if we will go to Kalman filtration, there will be first I will start with some introduction to Kalman filtration. Please first open tutorial 0.04 ukf.m. There will be about script description, what is inside. Input parameters is free Doppler components versus slow time. It is getting from AMPD. It is this free extracted frequencies. Then there is some UKF noise parameters for UKF. First is sigma 1 and sigma 2. It is these two parameters I already described. It is process noise and measurement noise. So process noise means how much the Doppler components are allowed to move, in which range of Dopplers. And sigma 2 is measurement noise, how much you trust in extracted beat from MMPD algorithms, how much I trust. It is good confidence, low confidence, and so on. And after you found it, you need to recompute, you will compute this amplitude, make averaging, and then you will find this Doppler frequencies, and then you need to compute all combination, because you don't know that first one was first sine wave or second sine wave, third sine wave, and so on. So you need to make 1, 2, 3, 1, 3, 2, 2, 1, 3, and all these 6 combinations, and make like difference between values like predicted and computed, and the slowest error, it is the best value. So first is extraction of Doppler lines based on AMPD algorithm, then UKF prediction filtration, resolvable label switching with permutation, because I don't know which is first, second one, and for each permutation we will compute the sum of absolute errors for each permutation, and we will take minimum. And this will be correction for UKF. So please open this tutorial and check. Output is how your Kalman filter follow this sine wave. And oh, sorry, that's again I have on primary screen, not on secondary. So figure 2 is error, figure 1 is look, 1, second, third sine wave. Why there is always problem? Flash. He don't know it. around this. So it is flash problem. Please again you can switch from mass from 0 to 1, and then you will load it real data or simulation data. So again, please try to also change, you can also change sigma 1 and sigma 2. It is depends if you will believe more in measurement or prediction. So you can tweak this parameter, but carefully tweak please this one. Remember that default value is 100, 100. With this value works relatively stable. So again, take 3-4 minutes and play with this one. For sure, try real data. So it is mass is equal 1. If you will just run with real data, you can see what will be result. Just play it with it. Try it with real data, try changing sigma 1, sigma 2, and also you can tweak parameter k, what is scale, number of kilogram, it is function, window function. So now we will continue to adaptive filtration with UKF. This is how to say, it is complete tutorial of UKF filtration, stage-by-stage logic of UKF. If you remember from previous lecture, it is just go one by one step from this 12 or 13 step how I have this tutorial. So try it, and there you can see what is output of real data, and this is please like transfer function of your filter, but like one slice is one filter, and of course you are changing this coefficient filter on time based on DSC, and multiplication with your original spectrum, you will get these results. So of course it will fail there because we don't concentrate into flash. But you can see MTI, and the rest also is relatively nicely suppressed. Of course, somewhere could fail. It could happen because it is not mean that work for 100%. It is real data. There could be some additional reflection. There could be higher reflection due to shape of blade, something, and Kalman didn't expect that will be so big changes because he also always make prediction on some behavior. So it is like this, and there you can see every error and average error.
Sir, like we can use also
I will go.
some clustering algorithm instead of UKF. Like for in ML, we can use curve fitting and all things.
I don't think so, because you need to, you don't have available the whole spectrogram, but you have always one spectrum by time, so you don't know what to expect. So you need to use algorithm classic filtration. So I don't think so that you can use this clustering method, because you know you don't have the whole record if you are working in real time, because UKF always works with present time and predict one time and again and again and again. So he don't know future. So with clustration, what do you want to cluster if you have only one spectrum?
like we can develop a model, like, and we can train our model with pre-recorded data. Then we can.
But you have. I will stop you. You have radar working in real time. What is pre-recorded data? It is previous tracks. Okay. So previous track that you have some movement of wind turbines, some kinematics of targets, but what tell you about how will they change in future? Not much. Okay, for 1, 2, 3, 4 prediction, for some slow number of prediction, you could predict if will be big plane. You don't expect that it will have this rotation and go back, of course. If will be some UAV, it could be really quick maneuvering, but I think that in this case it will be really hard to design this filter, because it will be must be definitely designed for completely different values, because kinematics, dynamics of this trajectory will be it will be huge. But for sure our filter will stop work completely, because he expecting 3 waves, sine waves, if you get my point. So yes. It will be I don't know, but clustering method like DB scan and all these methods, it is about grouping, how to say, grouping more points, and that is one target. I get you. It is like when you have hit your illumination by one, like 3 hits through 3 illumination, and it is not mean that it is 3 target. It is one target hit by 3 hits. Then you use clustering method, but it is just like for that you need to group these 3 hits and interconnect. It is one target. So I don't think that will work for this method. I think that you need to use just really some Kalman filter or some filtration method. I don't think that will work with clustering. It is for another purpose. It is just really that you hit targets more time, more PRIs. You need to tell him, okay, all this group of hit, it is one target. But imagine if you have 2 targets close to each other, and you get like point of like hits like 10 and 10, and it will be 10 and 10 points close each other. It will be really close. It will be really hard to separate, and maybe your clustering method failed and told you it is one big plane, not too small. But it is something else. It is clustering method is something else. It is using of course in radars. We don't talk it during second lesson about it, but this is use it very much. You need, because always imagine some really big ship, 300-400 meter ship or something like this. You know how many hits you will have, and you need to make clusterization. And it is now depends 2D clusterization, 3D, it will be cloud of points, and so on and so on. But no, for this you need to use filtration method. Okay, please open tutorial for not UKF but filter. Okay, there. Run it, and you will get transfer function and suppress it. So you can see how nicely suppress all this DSC component for some setting, and this is transfer function changing on time. And now we are going for complete algorithm. So please open. Okay, where is my mouse? Open after you finish work with filter. Open folder complete, and there you will see Kámen, Protivanov, Austria 1, Austria 2. So open Kámen and K01, and open please this K01 prediction DFF and this one with the date. So tutorial complete Kámen K01. And it is only measurement. Also, please check the wall algorithm, because there is just wall algorithm. You can recognize easily individual equation where we compute time delay, distance, range, and so on. Just please pass through the wall script first before you run, because you can easily change individual part that I mathematically described yesterday. It is just completely like equation that I show you. So just go one by one, please. Didn't work?
T01. Which file?
No. Just tutorial 4. Go tutorial 4. Yeah. Complete. Kámen. Yes.
T6.
Yeah. 2. Sorry. I missed K01, not K06. I think there you have. Sorry. It is just another data, so there is no problem. K06. And this second one, by the way, first one and second one, they are same results, only without, it is just graphic visualization. I make correction for a smaller screen. So we can pass through the wall algorithm on this. It takes little time.
Around 9 figures.
No, it is nice 9 figure, but unfortunately on my primary screen. So give me a second. You will run later another scenarios that is from individual measurement. Okay, you should see something like this.
Yes, sir.
Original spectrogram from Kámen locality, where we made first measurement. Yesterday you made analysis where you can find best place where we can measure. So we get this measurement. First we design MTI filter with some parameters. MTI filtration, static, tower is disappear. We extract in individual cuts 3DSC. There you have detail. Sometimes fail, sometimes not. Of course, close to flash fail. This is average error, so about 45 Hz. This is okay. This is predicted and extracted value. Sorry, this is what we how to say, what we select, which DSC. This is transfer function of our filter. This is after filtration. And now please you can run K0, 1, 2, 3, 4, 5. But on your screen, because always all visualization will be on primary screen, so I need always just changing. But always you can see 9 figures. It is one by one, one by one. This data are already pre-processed, so it works always with all this MAT file, all this measurement, everything. It is just about changing of name of this MAT file, but it is individual measurement, and it is for locality Kámen, locality Protivanov, locality Austria 1 and Austria 2. So just check that everything working. Please run one by one, special, maybe one scenario per one geographic place. Just check it that algorithm really works with different distances, different PRI, setting parameters. And I didn't mention all these parameters because you already have in tutorial 3 this length of pulse and all these things. It is just repetition, it is not necessary. So please just play it. Try open also Protivanov, try also Austria and Austria 2. I give you 5-7 minutes. If you have any question to any result, just let me know. And then we go for conclusion, because this is total, this is complete output, like visualization of individual step. Honestly, we usually present only first and after filtration. I don't need this individual step, of course. But if you want to check how design another type of filter or with another parameters and so on, so you can easily adopt it and check individual results. I think that there is all. Of course, there is some zoom and so on, but it is just for you, for more detail to present you. But we generally. So try open now Protivanov, if works for you, this result. This is Protivanov. Okay, see again around flashes.
Flashes.
Yeah. Transfer function, yeah. Then try Austria.
No, I did in Austria. Now I'm going to Protivanov.
Oh, okay. Yeah. Try Protivanov. It is little demanding. Of course, there is a lot of computation, so it depends on your PC. Yeah. Again, and when you open Austria, there will be this aliasing thing, because due to size of the blade, there was bigger blade speed, and it is start aliasing, so it is a reflection of this flash on other side. So just try open it.
I think we don't have Austria 2 file.
Yeah, maybe you have only Austria 1. Yeah. If you want, I can later upload also. So just. Okay, so it is some. Until it's warning, it is okay. Yes. Like this, exactly. It is flashes, and there also it is. Yeah. It is only small part of flashes. Always like reflection to other sides. So I hope that was enough proof from several sides that workings. Of course, it could maybe require for some really strong reflection or some bigger turbine, some tweaking of parameters of filter or something like that. It's possible, or tweaking of MTI filter or something like this. Of course it is, but it is not so hard. You have complete simulator model, so you just change one function and you could easily adopt it. But the general principle working. This is me. But you already saw it, you play with it now. I just want to show you locality Kámen, Protivanov, and okay, Grobschweinbach. I probably have a little different data. There you can see very nicely these flash reflections. Even after removing original, after suppression, still this remains, because it is this flash. Continue, we are outside, so we need to map to inside, and aliasing occurs, and it is still back and back. So, it was last slide of tutorial 4, and now I will continue with the last lecture, if never mind, or can we continue? I will just ask. Time management is important. So, we will look now to the whole story. We start Monday morning at 10 a.m. until 4 or 4:30 Friday p.m. 22 hours we spent each together. No, I'm joking. So there is just course review that we start. What is primary radar? What is range, Doppler, filtering, ambiguities. Then we description of wind turbines, radar crater, microdoppler. What is this phenomena? It was important part because we need to analyze. If we want to suppress something, you need to understand what do you want to suppress. Then we define mathematical description of behavior simulator, and of course we need to make validation of the simulator. So we designed, you already know how design measurement chain, what you require in principle. I told you that is in principle. I show you own solution because we have this equipment. If you have another equipment, it will be tweaking of some parameters, some setting of difference, carrier frequency, bandwidth, sampling rates, and so on. But now you understand why you need to choose these values due to connection, interconnection with radar parameters, because you need always measure something what is similar measurement in radar, and very often you can just borrow somewhere some radar and go to measurement. Also, I told you why it's important that we can go just take equipment and go measure. It is very dangerous. We need permission. So it was this one, and then we continue. Then I want to highlight how important before any measurement is analysis, like geo-analysis through map, through digital elevation model, and through line of sight. That you can't use just only 2D map or something like this, but always check real terrain. And one of the best tool, OpenStreetMap, how you could even through this overpass website, how you could extract only object that you are interested, and how it's very important and save a lot of time, how to say, this panorama or street view before you go to this location, and especially in your country. You are a big country. In our case, it is still few hours. In your case, it could be a lot of hours, of course. So, this is important. If you remember this Anenská Studanka site, there was almost impossible found even place for measurement because everywhere was woods, it was in mountains. If it was enough in adequate distance, there was some valleys and was some hills, something like this. So sometimes it is not easy to find even place where you could measure. And we end with lecture 7 and tutorial 4 that was today, and it was just related to our mitigation techniques, where main contributor was my colleague Karel Jurica. I need to mention them because I really thank you that I can cooperate with him on this. And lecture 8, it will be just conclusion, some limitation, what is open problem, what we can improve, and future work. So, if before our future, what we can do it, where could be improvement, you already know that wind turbines behave as strong time varying, and it is the worst, moving clutter for primary radars. Close to airport could be disaster. Echoes is very variable RCS, radar cross section. Why Doppler spread? It is depends of course on speed of wind turbine and length of blades, if I could simplify it, and of course shape of blade. And this behavior has a strong masking effect. So weak targets could be masked or just disappear from your radar, and it could be very dangerous situation in case that will be, like imagine that you have some small aircraft around wind farm and now you are lost both of them and you can't control where are they, so it could be dangerous. This also depends, we also make exploration inside what is inside radar signal processing, not from point of view hardware but more in software and block processing chain. So now you know why we select each frequency band, PRIs, pulse width, beam width, what is range Doppler resolution, and so on and so on. How we can make visualization of outputs on radar. It was this A scope, B scope, C scope, and PPI from different point of view, and so on. So I hope that if you don't know with this information, it will help you now little understand what is inside radar. That usually when you go to close airport, you see not exactly radar, but you see only antenna of radar, if I can say. But there is much more things. So I hope that maybe you will start liking this area and will start working in this area. There is a lot of different opportunities also for job, antenna design, amplifier who likes analog techniques, power amplifiers, AD conversion who like only software design, algorithm design, signal processing, tracking algorithm. Now in present system and in future system, for sure you don't want to know only there is target, there is kinematics, there is his kinematics, there is this position. You also know what is type of target. It is helicopter, it is some small, it is ship, it is small plane, and even it is still improving, and future will be that based on RCS signature, I think that in soon future we even can recognize. So Like example for UAV, you will detect UAV, you know where it's going, you know kinematics, everything, and later you will see from behavior, okay, microdoppler, it is 4 blades, so it is quadrocopter, and from behavior of quadrocopter maybe you will recognize, okay, it is Maverick 4 or something individual type. It is open future. But of course, a lot of methods of this signals processing is extremely numerically demanding. But we have still more and more powerful computers, GPU computing and all these things. So algorithm that was not possible use, even that are known before 10 years, we can use now, and we will see what will be after 10 years, where it will be. Also, there is important that in present time start be very interesting fusion of information from different sources. Imagine that your radar also have access to some precise GPS or ADS-B, so it is mean that in same time when he measuring reflection and all these things that I mentioned, he also receiving information from secondary like ADS-B recorder, so he know, okay, there is some plane, it is this Airbus 77, I don't know. So you could make fusion from different sources. You could use also information, public information from OpenStreetMap or military maps about position of wind turbines, and so on and so on. So it is not only about radar, it is about fusion information from different, totally different domain. And if you, and you know it, if you have more information, you are clever, you are better picture. And it is always like. So, what we achieve, we make the whole wind turbine eco-modeling, we design model, and then we design mitigation algorithm. I can say that I hope that I also introduce how make this measurement campaigns, how important is metadata. I will again highlight that is extremely important, and what exactly what do you need. Then last one was mitigation concept. I will not repeat it because we just finished it, it's clear. And now I would like to highlight what is future work, and it will be probably very demanding. Maybe you have some more idea what could be improved, because we just think about few things. I think that very interesting looks multi-sensor cooperation. Why? Imagine that you have multiple sensors in different position. Wind turbine is static object, of course, in one place after installation, only blade is rotating. So in case that I can't see, how to say, targets from my radar, but maybe could be visible from another radar. If I have multi-sensor fusion, okay, you lost information due to position of blade, but if for my radar is bad position, strong reflection, everything goes wrong, it is mean that from other side could not be so bad. So multi-fusion, I think that is also future of radars, but it is not easy because you know that radar works in local coordinate system. If for one radar is target like 1 kilometer far away, for second radar could be 10 kilometer. It will be second radar, second target, and for first one will be 5 kilometer. For second one could be kilometer. How you want make decision? How you interconnect this multi-fusion information? How you can be sure that how you can want interconnect this to correspond to one target? And 1, 2 target, okay. In the worst case, you will try all combination and one will be best. For 20, 40, 50 targets, forget. A number of, imagine if you have like 3 radars, 50 targets, number of combination will be 3 to 50. It's a lot of combination, and only 50 of them will be correct. The rest is lie. So this fusion information is also not easy task. Application of cognitive principle, we just discussed it with your colleague about cognitive radars. So it is a perfect example. It could be include utilization of meteorological and wind turbine control data. So do we have some site where is information about wind turbine parameters, that wind turbine now rotating speed is 7 RPM? Can I use it like another source of information? If yes, it will be perfect, because then if I know this base parameter or rotating yaw angle, then I can predict that this is reflection from this specific wind turbine, because I can model it, and so on and so on. So different domain of source of information is important to make fusion and fusion. But imagine, it is relatively easy to say, but everything needs works in a real time. You don't have so much time think about these different sources, how combined. It is completely different format of data, and still you need to work in real time. If computation will take 3 minutes, it is nice, but after 3 minutes in standard plane you will be far away, and it is outdated information. So this is second thing. Then adaptive configuration of signal and data processing. It is now a huge task, and I think that will be close future. What is mean? Example that I have target that is hardly visible for some setting. Okay, I need some logic in my sensor that okay, there we probably is target but is hardly visible. I don't know what is this. So he will automatically change length of pulse, intermodulation, some all from thousands of parameters, and automatically set and measure again, but automatically. But please don't consider that is automatic like machine learning on AI. No, this must be controlled logic. So maybe in some late future will works like this, but I would like say optimization of radar resources, it is better. Don't expect like it's really popular now that is everything is AI or something. No. You don't have control, and you need to have 100% control on the radars. It must be predictable device, how operate in which scenario. And of course future work, it will be nice if we will have possibility implement this some mitigation technique and some these things to real radar sensor to signal processor and validate that really works on a real radar. And it is depends of course on which type of radar, and it is depends on, this is tightened with industry cooperation of course. Okay, after finishing ceremony, I definitely will ask your feedback on course, so then you can hit me if you like it or not, or give me suggestion, or what should I make more extension, what I should I suppress, and so on, because of course we are, me, Karel, we doing our best thing, but just we are 2-3 people who working on this course, so we need more opinion. So please, if you don't want say me personally, or you don't know now, later you have my email in every slide, at the end slide, so just send me email, because there is always space for improvement. So I really want to thank you for participation on this course. I really appreciate it. I think that we have good time during even lunch or tea break or coffee breaks. I think that we discussed a lot of things, not only from this area, but even from personal area. So it was really refreshing. It is always nice met new people, and I hope that through your especially mentors that I know very well, we will be in touch. So thank you very much, and it was last slide from my side. Thank you very much.